All right, today we're going to talk about is conditional probability. So when we're talking about conditional probability, it's a probability of an event given, that's going to be our keyword here, that another event has already occurred. So the formula for conditional probability is, let me write this here, this little line, you say that as given. Let me do my G a little bit better there. There it goes. All right, so this little line here, you read it as the probability of A given B. All right, and that's going to equal the probability of A and B divided, or A then B, excuse me, divided by the probability of B. All right, so when we look at this, think about the probability of A and B, you're going to multiply those together because you're using and. So when you're using the and, you're going to use multiply. And I just drew a little Venn diagram here so we can kind of see, especially once we get down into this part. All right, so remember, independent denominators stay the same. If it's dependent, your denominators are going to change on depending on the situation, what's happening. All right, so let's given that a toss of a die is even. What is the probability that it's divisible by 3? Well, if it's divisible by 3, we have two options out of 6, which gives us 1/3. And if it's even, you add 2, 4, 6, which is 3 out of 6, which simplifies to 1/2. So now we know that A is 1/3, B is 1/2. Now we're going to go ahead and we're going to start plugging it into our formulas. So we have to find what A and B is first by multiplying those two. Because remember, and you're going to multiply. So 1/3 times 1/2 is 1/6. And then just the probability of B is 1/2. So now we're going to put it all together. We're going to say the probability of A and B, and that's going to be divided by B. So 1/3 times 1/2, all divided by 1/2, which will equal 1/3. So it looks a little complicated, but actually it won't be too bad once we get going with some of the things. And then my little diagram here is just showing you A is here, B is here, and this is where it's happening for both. So we're basically taking this and dividing it by B. All right, so let's go ahead, let's start this first one. All right, so a sports survey taken at school shows 48% liked soccer, 66% liked basketball, 38% liked hockey. Also, 30% liked soccer and basketball, 22% liked basketball and hockey, and 28% liked soccer and hockey. Finally, 12% liked all 3 sports. So we're going to find the probabilities, and remember when you're talking about probabilities, it's going to be in a fraction or a decimal. All right, so our first one says Gina likes soccer if she likes basketball. So we want the probability of soccer and basketball. So we know soccer and basketball is right here. And the probability of just basketball is here. Oh, I think I need to use a different color for hockey. Yeah, I do. I think I highlighted the wrong thing. My bad. All right, let's go here. Soccer and basketball. Here we go. Okay, sorry, I highlighted the wrong thing. All right, so here we go. So now we're going to take this, convert it to a decimal, take this, convert it to a decimal, and you can go ahead and divide it or make it a fraction. So this is correct, or 5/11. So that's the probability. All right, now it says Chad likes basketball if he likes soccer. So first we need to find the probability of basketball and soccer. So here we go, it's 30%. But now we need to find, since it says if he likes soccer, so this is given he likes soccer. So this is what the 48% is going to be your denominator. All right, and go ahead, combine those two. You can write it as a decimal or you can write it as a fraction. Either is fine. All right, so go ahead. I want you to try this using the information up here. So remember, it's saying if she likes basketball, that's going to be what you're dividing by. If he likes soccer, or given that he likes soccer, that's what you're going to be divided by. So just go ahead and try those two. All right, so let's try this next one. And it says, in a survey, 53% like cats, 42% like dogs, 10% like cats and dogs. Find the probability that the person likes dogs given that they like cats. So we know, given the cats, how many people like dogs and cats, and then figure that out. So dogs and cats, or cats and dogs, is 10%, which is 0.10. And then we're going to divide that by the probability of cats, which is 0.53. And then go ahead and enter that into your little calculator, and I believe that's rounded. And then, or you can write it as a fraction, either is acceptable. All right, this next one is Albert tosses 3 coins. What's the probability he's tossed 2 heads, given that he's tossed at least 1 head? So this is the clue to tell you what your denominator is going to be. So what I did is your 3 tosses are here, and these are all the options. So this is all the options that you could potentially have here. All right, so we need the probability that he tossed 2 heads. And so in this case, I got 1, 2. So these 3 options out of 8 total, we're going to divide that by at least 1 head. So we can't use that one because that's all tails. But these have at least 1 head. So like I said, we're not using that one. So that's going to be, we've got 7 options here. And that's divided out of the 8 total. All right, and then go ahead and you'd multiply by the reciprocal, and then you'll get 3/7 as your answer. All right, I want you to try these. Now, I gave you a little hint here. I set up a Venn diagram for you. And then once you get these here, you can start to figure out the probability a student listens to pop music given they listen to country. So remember, this is going to be the denominator, and pop music and country would be the top. All right, so that's your hint. Go ahead and finish those. And then we'll go over those in class also. All right, now we've got two-way tables. Now you've done two-way tables before, but it's probably been a minute. So just as a quick reminder, your joint frequency are the individual points within. The marginal frequency are your totals. And that's exactly what I just said here. Okay? All right. So this looks crazy down here. I was just kind of color coding as I was filling out this information. But the table shows people in a youth soccer league make a two-way frequency table. So all I did is I just went through and I counted how many males. And so I knew that I should have 20 total because I counted those. And then I broke it down. Okay, how many males are between 3 and 5? So I knew that I've got, 1, 2, 3, 4, which is right here. And for females, I've got right here. And then now it said 6 to 8. So I'm looking at my 6 to 8 males. So if it's 6 to 8, I've got 1, 2, 3. And that's it there. And then I just went through and I completed all of this for you so you can copy it down so we don't have to spend the whole time doing this. So just a quick thing, your joint frequency would be all these numbers in here. Your marginal frequency would be the totals right here. And then, there you go. And then this is your grand total. So this would be the total number of people that voted or total number of events that occurred. So this is your grand total. All right, now let's get started since I organized the information for you. And we want to know what's the probability that it's a female. Now, it's just asking for females out of everybody. So what we're going to do is we're looking at the female total, which is 16. And that's out of everybody, which is 36, and simplify. Now we're looking for the males that are 9 through 11. So we're going to go here and here, and we're going to see they intersect at 3. So that means they're both male and between 9 and 11. And it didn't specify out of what category, so you're going to take it out of everybody. And then you'll get 1/12. All right, now I'm looking for 15 to 17 years old given, oops, my G's messy there, that they're females. So we're saying of the females, so you're going to look again at the 15 to 7-year-olds which that are in the females. So right here, so you've got 15 to 7-year-olds that's in the female category out of 16 total. So this 4 over 16. All right, now we're going to look at females given they're 15 to 17-year-olds. So now we're going to use this total right here, and that's going to be 9. And we're looking for females that are 15 to 7 over all the 15 to 7 years olds. All right, I want you to go through. I want you to answer those questions using this information here. All right, now I filled out the table for you, but when you have this, I filled out the 2 totals here, I filled out the totals here, and then that's going to bring you to 500, which is the grand total, which would be all the number of students surveyed at the school. All right, so what's the probability that a student walked to school? So it's saying how many walked. So you're going to look at your walk category. You're going to use 88 out of 500 total. And then that simplifies to 22 out of 125. Now the probability is a 9th or 10th grader. Now even though this says or here, the category is 9th or 10th. So we're going to use a probability of 9th or 10th. So we're going to look at all the 9th to 10th graders, which is 210, out of the total survey, or kids surveyed, which would be 21 over 50. Now it gets a little different. It says probability they rode the bus, or it's an 11 to 12th grader. So remember, you could potentially have 11 or 12th graders that rode the bus. So remember, you got to subtract those that are both. So the or means we're going to be adding, but we may potentially have to subtract some that are both. All right, so the probability they rode the bus, which is 147 out of 500. The probability is an 11 or 12th grader, which would be 290 out of 500. But now the ones that are both. So it would have to be rode the bus and 11th or 12th grader, which is 41 out of total 500. So we're subtracting those because we've already counted them. All right, and then you get 396 over 500, which simplifies to 99 over 125. All right, and this one says, what's the probability a student is an 11th or 10th grader given that they rode in a car to school? So if we have the if or given, that's when you need to divide. And then you're going to use the rode in the car as the total because it says given they rode in the car. So you're going to look at the rode in the car. Where's your car writers? Are there? You're going to use this total here. And the 11th or 12th graders would be 184. So of the car writers, 184 were 11th or 12th grade. And then that's going to simplify 92 over 127. All right. Now, what's the probability that they walked given they're 9th or 10th graders? So remember, this is going to be your total. So we're going to look at our 9th and 10th graders, which is 200. Oh, I'm sorry. Oh, yeah. Okay, sorry. Yeah, 210. Sorry, I had a brain fart for a second. Because we're going to use this as your total. And then now we want to know of the walking 9th and 10th graders. And that's going to be our numerator. All right. And then when you simplify it, you'll get 1/7. So a lot of this is just making sure you're reading it carefully and then just double checking. So from that, make sure you fill out your table and then make sure you know which column you're using. All right, so what I want you to do is you're going to complete this one. Make sure you fill out your totals, and then go ahead and answer the questions, which is probabilities. All righty? Oops. And then that is conditional probability and two-way tables.